All right, now we're running. All right. Chapter 16, the nature of solutions. By the way, we're going to be reviewing on Friday. I want to be reviewing our benchmark from yesterday. So if you haven't taken it, you're going to have to come see me. For those of you that haven't taken your benchmark. All right. So first thing we have to define with solutions are mixtures. Okay, there are two major kinds of mixtures. The first one is heterogeneous. Heterogeneous is when you have visibly different parts. Okay, now there's a whole other name that I like to call it. Okay, I made it up. It's not really a word. I made it up. Okay, it's telemapartable. Okay, in other words, when you mix things together, you can see the different little bits and pieces that are in there. Okay, that's telemapartable. You can see a heterogeneous mixture. You can see the parts to it. Okay, like dirt. You go outside and take a handful of dirt and you can see all the little pieces inside. That's, well, first of all, I am Irish. That's beside the point. I really am Irish, yeah. Okay. Can I zoom in? All right, I suppose I can make it bigger. How's that? Is that better? All right. Although you have it right in front of you. Okay. Teleportable. All right, now get over the fact that I'm doing an accent. Okay, listen to what I'm saying, not how I'm saying it. Okay. Yeah, so teleportable, that is a heterogeneous mixture. So you've got, it's when you can see the little bits and pieces that are in your mixture. Okay, the opposite to that is a homogeneous. This is when the parts are not visibly discernible. Right? You can't see the individual, like chocolate milk. You know there's different stuff in there because you put the chocolate in the milk, but you can't see the chocolate. The whole thing's brown, but you can't tell which part's the milk, which part's the water, and which part's the chocolate, right? So that would be a homogeneous mixture. The parts can't be distinguished from each other. A homogeneous mix is also called a solution. Okay, so if you can see the parts to it, it's not a solution. If you can see the parts, it's not a solution. Okay, air, usually, is a homogeneous solution. We've got nitrogen and oxygen and carbon dioxide and all these other gases that are in the air. It is a homogeneous solution. Get it as text. Knock it off. That would have been funny if all of a sudden, the only time I lecture is in its accent in the middle of the year. Oh no, I'm not really Irish. No. So we have an official definition for a solution. Okay, it's a homogeneous mixture of two or more substances in a single physical state. Well, let's go back to the air analogy. Sometimes in Fresno, it's not always a homogeneous mixture in the air. You know, every once in a while you're going to see, like, you'll see layers to the air, okay, and you'll see like a brown layer. Particularly if you head up to Shaver and you look back, you're driving up the far lane on your way up to Shaver, and you look back over the valley and you can see like a clear layer and then a brown layer and then a clear layer. Have you guys ever looked at that? Look at the air. Oh, you can do it, but don't look back, because you do it once and then forget it. Erase it from your mind if you can, because that's reminding you of the crappy air that we're breathing here in Fresno. It's horrible. Okay, so our examples for our solution is going to be Kool-Aid and air and soda pop and sterling silver. Okay, sterling silver, like, you know, your silver that your parents, you know, the nice silver that your parents put on things, that sort of thing. It is a solution. It's not 100% silver. It's mixed with hardening metals that allow it to that allow the metals to to make the silver stronger. What's that? Okay, question so far. No. All right. B, properties of solutions. The particles in a solution are very small. They exist as atoms, molecules, or ions. Okay, all of the particles in a solution can pass through filter paper. So think of it like this. Have you ever made coffee before? Okay, well, you make the coffee, you grind up the ground, you put them in the filter, and then you put the water in the machine. If that's how you make it, I put mine in the machine. And the water, heats up and pumps through the filter. And what passes through? Well, you make the coffee, right? But it's not the water, it's brown water, right? Not that kind of brown water, but brown water. Well, there goes Mr. Allen again, making his poop jokes. Okay. But the reason why it's brown is because some of the coffee has passed through the filter, and so what you have is the solution. Okay. Now the grounds that she's kept up out of the filter, if those were in the coffee, it would have become heterogeneous mixture, right? Because you could see the coffee grounds in the water. No? Yeah? Or when you drink it, all of a sudden you get the little chunk of coffee ground in there. It's like, yeah. Okay. But if you don't have the coffee grounds, it's a properly made coffee, then you have a solution and the brown stuff. But there's stuff that you put into the water. Okay? And so, but it's dissolved in the water, and that's the solution. So all the particles could pass through the filter paper. Okay, the particles are very, very small. Now, particles are evenly distributed on a molecular level, and they will not separate no matter how long the solution sits. It'd be kind of gross. Let's say you buy a bottle of Gatorade at the store. Okay? It'd be kind of gross if after a while all you see is the water on top and all the Gatorade particles sitting at the bottom of the... Right, it doesn't do that, does it? No, because the salts and the sugars and the flavoring are all dissolved. Okay, they're in solution and they're not separating out of the fluid. Okay, so that's why the Gatorade that you have in there is a real solution. Okay, so we got two parts to a solution. The first one, okay, the substances that are dissolved in a solution are called solute. There can be multiple solutes in a solution. Okay, so those are the substances that are dissolved in a solution. Then the other one is solvent. Okay, so the common way to remember these, if you're looking for an example, let's just take some salt water. Solute is going to be the salt. I don't like that color. Let's turn that blue. Purple. I like that better. I'm not taking y'all making fun of me. Alright, the other one. If salt in salt water, if salt is the solute, then the solvent would be the water. No, that's how I want you to remember it. You've got solute and solvent. Okay, so solute is going to be the salt, and the solvent will be the water. Did you follow what I'm saying? Yeah. Okay. Sounds like I'm saying what? Butter? Butter? Sounds like I'm saying butter? You mean you can't believe it's not butter? All right. Okay. However, there's another way I want you to remember it. Okay. The solute is the stuff you put in. Okay, if you're making a solution, the stuff you put in is the solute. All right? The stuff you put it in is the solvent. So you got stuff you're going to put in, and the stuff you're going to put it in. Right? So if you got salt water, you got the stuff you're going to put it in, that's the water. So that would be the solvent. And the stuff you put in there is going to be the solute. It's important for you guys to understand the difference between these two. I guarantee you're going to have a question on your common assessment on your benchmark, and on your STAR test. Okay, you're going to be given a list of things. This is, this substance and this substance and this substance and this substance, and one of them is going to be the solvent. Okay, and you're going to have to identify which one it is. All right. So knowing the words solute and solvent, you're going to have to know the difference between the two. All right, where were we? No. So, to take the immortal words of a really crappy movie, there can be only one. There can be only one solvent in a solution. You guys know what that's from? I heard someone. Did I hear someone say it? What was that from? Tom? What movie? No, I thought I heard it. Did you say it? No. Have you ever seen Highlander? Oh, you know what I'm talking about then. There can be only one. Okay. They're these immortals and they start killing each other. Because all of a sudden they decide that there can only be only one immortal. So, which is kind of funny because how can an immortal be killed? If you're immortal, you're not supposed to die, right? All right. Okay, so there can be only one solvent in the solution. So let's say we've got soda pop. If we've got soda pop, Coke, Pepsi, whatever you want to call it. Okay, Mountain Dew, Jolt, ginger ale. Okay, in your soda pop, you've got the sugar, you got the flavoring, you got the CO2 dissolved in there. You've even got a gas in the solution, in the gas in your solution. Water would be the solvent. It's the most abundant substance in there. Okay, alcohol and water. They are completely miscible. We'll get there in a second. So alcohol and water can completely mix with each other in any proportion. So when you mix them together, whichever one you have the most of, that's going to be the solvent. Some of your parents back at home in their liquor cabinet might have a bottle of a Bacardi 151. Okay, Bacardi 151 is 75% alcohol. Okay, and 25% water. So in that case, which one is going to be the solvent? The alcohol is going to be the solvent, and water is going to be the solute. You actually have water just diluting the alcohol a little bit. It's not, it's not a whole bunch of water with a little bit of alcohol in it. It's a whole lot of alcohol with a little bit of water. There's actually some other, it's not legal in California, but there are other states that sell, it's called Everclear. Have you ever heard of Everclear? It's 190 proof. 190 proof is 95% alcohol. Yeah, no, that's entirely different stuff. Rubbing alcohol is not consumable. You don't want to drink that stuff. That'll kill you. Right? Now the regular, the ethyl alcohol that you can't drink, that's, mind you, I realize that you're all minors. You shouldn't be drinking the alcohol. But you're taking chemistry now, and so now's when you learn about it, and then you learn about it now, then you discover it later. So this Everclear stuff is 95% alcohol, and it's sold in stores. Not in California, but like my brother used to live in Colorado, and he'd bring me a bottle every once in a while. Not that I drink it straight. God, forget growing hair on your chest, it'll grow hair out of your eyes. That's nasty stuff. But you put it into like punches and stuff, and it's never mind. Looks like I'm not going to be saving this recording. All right. So, when you have soluble substances, those are this is when you have solutes that have the ability to dissolve in a particular solvent. Okay? Insoluble substances are when they don't dissolve. Okay? Take dirt, for example. Depending on the size of the particle. Or take a clod of dirt and crumple it up and pour it into a bucket of water. Okay? Yeah, you'll make some mud. Okay? But then after a while, what's going to happen to it? Okay? Well, it'll turn back into dirt if you get rid of all the water, but what's the dirt going to do when it's in the water? let's say it's a clear bucket. What are you going to see? Yeah, all the particles are going to sink down to the bottom because dirt isn't soluble. It is insoluble in water. Okay, and so now there might be some salts and some minerals that are going to dissolve, some ions that will dissolve in the water, but most of it is just going to sink down to the bottom after time, and that means it's not soluble. It is an insoluble substance. Okay, and so we're going to be, in fact, on the back of your notes. Should be on back. Is the back of your notes, the back of your homework? No, back of your homework. Sorry, the other packet. I've given you guys a solubility chart. Okay, and this is, there's actually some substances have varying, that's a difficult word to, have varying solubilities. In other words, they're going to, depending on the temperature of what you're dissolving them in, sometimes it'll dissolve more, sometimes it'll dissolve less because of the molecular motion of the solution. But there's a limit to which things can dissolve, to which many things can dissolve. Some things can dissolve completely. Salt you can dissolve forever in water until you have more salt in water. Okay? Other things, only a certain amount. And so we have varying amounts of insolubility. So, for example, alcohol is soluble in water. Oil is insoluble in water. In fact, we use this. You know, this is one of the basic reasons why we're alive. We've kind of talked about this before. Remember we talked about the lipid bilayer? We talked about polar and nonpolar molecules before? Okay. You don't remember us talking about polar and nonpolar molecules? Go back in your notes. They're there. But with the lipid bilayers, we've got it kind of looks like this in biology. If you remember that, you got the long stringy chains of lipids that are facing each other in the membranes of our cells, and on the outside we've got polar regions which can dissolve in the water. Well, that's why because our solvent, the universal solvent of this planet is water. Our life has evolved in the way that we have these membranes with the lipid bilayer staying away from the water and the other ends staying in the water. Okay, so this whole idea of oil is insoluble in water, okay, oil is a lipid. This is one of the principles on which life is founded, because that's how we make our membranes. Okay, so alcohol is soluble in water, oil is insoluble in water. There isn't any solute that will dissolve all solvents, and there's no solvent that will dissolve all substances. There's no solvent that will dissolve it, right? Water doesn't dissolve everything. Okay, and you know there's no absolute, there's no grand. You know, you may hear water is the universal solvent. No, it's not universal. It dissolves a lot of stuff, but not everything. Yeah, there you go. That's the next thing. Water is called the universal solvent because it dissolves a whole lot of stuff, but not everything.